So in this case, we are going to consider another typical exam revision as we are preparing for the tests and also for others who are actually preparing for the exams which are ahead of time. So this is as a request so that we can work on this previous test, which was just written currently on 24 of February 2025, and that was on the quadratic equations and inequalities. All right, so that is from this school. So we are going to consider the questions. Unfortunately, we were not given the instructions. Maybe the instructions were written on the board, which is important for you to have instructions whenever you are writing a test. All right. It is very, very important for you to be given or to have instructions. So, anyways, we're going to have our answers as usual, two decimal places, and make sure that your calculations are properly shown, showing the steps, formulas that you have used to solve or to simplify a typical question. So, without wasting time, guys, we're given question number one. Actually, that is question one and question two. So it was just like, guys, I do not know how. Like question one was consisting of one, two. All right. I don't know. It was supposed to be maybe A, B. Okay, no problem, guys. We're just going to answer as it is. All right. So this is the first part that we have on question number one, where we are given x minus 2 over 3x is equal to 5 over 3. For what value or values of x? So maybe we're going to have 1 or 2, depending with what we have. So for what value or values of x is this equation undefined? So we start by the undefined part. For this equation to be what? To be undefined. All right. The given equation is given as x minus 2 over 3x like this, which is equal to 5 over 3. Then they are saying, what are the value or values of x that we are going to have this equation being undefined? Being what? Undefined. What are the conditions? All right. When we are referring to the undefined, remember that's a condition where we've got a constant over a zero, a certain number, whatever, it's a constant, it's an expression, whatever that we've, but the denominator, guys, we do understand that the denominator is not supposed to be equal to zero. In that case, we are saying this is what? Undefined. It cannot be simplified in our mathematical simplification. So when we are given, maybe it is 1 over a 0 like this, we cannot simplify this. As you can see, that's met error. Cannot be simplified. So this is the condition if the denominator is equal to 0. So understanding your fractions, guys, we're going to notice that definitely here, even if you're going to have it as a single fraction, what was going to happen? You're going to take the LCD of 1 and 3x, which is what? Which is 3x. Whatever, guys, we do not even want to know what you are going to get here. We do not even want to know about that. We are not even worried about that. That does not make our function or this equation to be undefined. That part does not make it to be undefined. What makes it to be undefined is our denominator when we are given a fraction. The denominator, this part, when it is equal to what? To 0. When the denominator is equal to 0. So in that case, we are saying our denominator, which is the major case, 3x, must be equal to 0 for this to be what? Undefined. Once this denominator is, guys, as long it is equal to 0 here, as long you put a 0, whatever that we are talking about becomes senseless in our mathematics. So we take that now to be equal to, so we are done. We have an equation. So what is that you need? Remember, the question is the value or values of x. We must solve for x. We have an equation here. So let us solve for x. How? Divide by 3 because we are multiplying here. So we're going to multiply, we're going to divide by 3. Thus x is equal to what? 0 divided by 3, that's a 0. Guys, the denominator is not supposed to be equal to 0, not the numerator. The numerator is not a problem. The numerator divided by anything, guys. When the numerator is 0 like this, you get a 0. This one can be simplified. This one can be simplified. Use your calculator. 0 divided by what? By 4, you get a 0. That is 0 over a certain number, any number that you want. You get what? A 0. What we do not want is to have the denominator like this. This is the major case. Our denominator here is the one that we are worried about, to say our denominator is not supposed to be what? Is not supposed to be 0. Once this denominator is equal to 0, guys, we cannot simplify whatever that we are seeing. As we can see, it is what? It cannot be simplified. Made air. Cannot be simplified, this part. So please be careful in your simplification. So that is the case, guys. Anyways, let us consider another part of our question. All right, so here I just gonna, all right, let us go back to our question, guys. But as you can see, that was it. So if you consider the other part of our question, we are given on 1.2 without, they are saying without solving the equation. Determine the nature of its roots. The equation, this is an equation that we are given there, guys. We are given an equation. This one, an equal sign. That's an equation there. So they're saying, without solving it, do not solve. No, do not solve. But determine the nature without solving. Remember, guys, your nature of roots when you work with the delta. For the nature of roots, we work with the delta, which is your b squared minus 4ac. This is the one that can give us the nature without solving. So it is only possible if we can see our equation in this format: ax squared plus bx plus c is equal to 0. If we can see our equation like this, therefore we can apply this. So guys, are we having a quadratic equation in this format? That is the question. We do not have. Look at what we are given there. We are supposed to rewrite this into this format. All right, so let us take our equation, work on it. X minus 2 over 3x. 2 over 3x is equal to 5 over 3. We are supposed to rewrite this equation to be exactly in this format so that we can talk about what? This delta concept, the discriminant. So what can we do, guys? We have to consider the LCD of the given denominators. This is same as over 1. So considering the denominators that we are given, guys, we've got 1 here, we've got 3x, and this is 3. So what is the LCD in terms of the numbers 1, 3, and 3? Is going to remain as 3. That one is going to be 3, guys, because 3 is common here. So you're going to have 3. Then in terms of x, we only have x here. So just going to take as it is. So this is going to be our lowest common denominator, our LCD or LCM. That we are going to use. Remember to remove fractions. We need to remove fractions. So you multiply each and every term by the LCD. So multiply each term. In this case, by what? By the LCD. So that is the consideration, or the LCM, depending with the way that you understand there, which is what? Which is this 3x. So you're going to take that 3x, multiply each and every term. So here we're going to multiply by 3x. It's just same like 3x over 1. We multiply by 3x. Just like 3x over 1, we multiply by 3x, like that. So let's multiply, guys. 3x times x, that is going to give us what? 3x squared. X and x there will give us a squared. Minus that, guys. This one is just going to divide it. Remember, 2 over 1 is a 2. So whatever divided by 1 remains as it is. All right, so that is it. This one is going to cancel the 3x, and this 3x going to cancel. So we're going to have minus 2. Minus 2 over 1 is what? Is minus 2, which is equal to, here, what was going to happen is that the 3, this one, and this 3 was going to cancel. But there's x, which is remaining. Take note, there's an x there. So it's 5 times this x, which is what? 5x. So that is what you're going to have. We have multiplied each and every term by the LCM or the LCD to get rid of what? The fractions. As we can see, we no longer have the fractions. But still, we do not have this format. This format, guys, simply tells us that one of the given sides must be equal to 0. That is what we can see. From our format here, it simply tells us that one side must be equal to 0. So we need to get that side. So what are we going to do? That is the consideration, to get that to 0. So we are going to take this to the other side. All right. So transposing or taking the 5x to the other side of our equation, we're going to have 3x squared. The 5x will be what? Minus 5x. Already there is a minus 2 there. All right. So that's equal to 0. What we want is to get rid of this term. So we have a normal quadratic, the way that we are used to on our quadratic equation, where we can properly see A, the coefficient of what? X squared. Where we can properly see B, the coefficient of what? Of X. Where we can properly see our constant, which is what? The constant as it is, the minus 2. So these are the ones that we want, the B, the A, and the C. So in our case, what is our A? The coefficient of X squared. So our A is 3. Our B, the coefficient of X, which is negative 5. Our C is the constant, which is negative 2. So let us take these and put them here because we do not want, the question, guys, is saying, let's go back to our question, because this is our quadratic, but they're saying without solving the equation, without solving. If you were to solve this equation that we had, which was given as a fraction like this, still you're going to do the same thing, as you're going to remove the fractions and you have this part. Then you solve for x. But they're saying without solving. That is why we are supposed to concentrate on our delta, finding of the discriminant. So our discriminant, which is our delta here, is what? B squared minus 4AC, where our B is what? Negative 5. So that's negative 5 squared minus 4 times our A, which is 3. In this case, that's our A, and C is what? Negative 2. So this is what you're going to have. So you're going to simplify. That was going to give us, all right, 49. Guys, you can just use your calculator here as it is. All right, let me just do something, guys, here. Do not worry about this one. It does not affect our calculations. Okay, no problem. So this is it. Negative 5 squared minus 4 into what? Into 3 as it is, then open bracket, negative 2 as it is. So that is, you're going to obtain what? Positive 49. So this is what we have. So as we can see, our delta is 49. The question is, we are supposed to determine the nature. So let us look into this number. Remember your nature of roots, guys. We actually compare to 0. Starting from 0, a number that is less than 0, or we are going to have a number which is greater than 0. So in our case, we can see that this delta is a number which is what? Bigger than 0. Our delta, this one, it is greater than what? It is greater than 0. Not equal to 0. It is greater than 0. But not just only equal to 0. You are supposed to test this to see, is it a perfect square? If in case that you do not know your perfect squares, how do you test? Just introduce the square root on your calculator. Square root of the answer. You can see that we are obtaining what? A whole number there. We are obtaining a one that is. This is a perfect square. The square root is giving what? A rational number. That is, we are having that as a perfect square. So 49 is not just an ordinary number. It is a perfect square. So this is what we have in our concept here. We have our delta, our discriminant, as a number that is greater than 0. And also it is a perfect square. So what is going to be the nature? So therefore we can say the roots are what? To be greater than 0, there we are just referring our roots are supposed to be what? Real. Supposed to have a real values. If it is less than 0, we do not have. This is what? Non-real. We do not have real values there. All right? That is the non-real part. Being greater than, being equal to 0, that is where we start to be what? That is where they start to be real. And the special part there is that we're going to have rational and equal. But when they are greater than 0, the real part is still there. And we are talking about what? These roots, they are unequal. Unequal. As long they are greater than 0. At 0 there, that is where they're going to be equal here. They will be real, rational, and what? And equal. But here they will be what? Unequal. So from this concept alone, we are saying these roots, they are real and unequal. But because it is a perfect square, these roots are going to be what? Rational. That is the major part of being or testing that is it a perfect square, because it can be greater than 0, but not a perfect square. Meaning to say it's just a condition of what irrational numbers that we be having. But when it is a perfect square like this, it will be under rational numbers. So we can say the roots, therefore, in this case, the roots are what? Real. That is the first thing. Then we're going to consider rational and unequal. Remember the unequal part. Right? The only equal is when it is equal to 0. That's when they are equal. Non-real less than 0. So this was the consideration of our question. You're going to have your quadratic equation the way that you're used, but you're supposed to have it under the discriminant way, not to solve it. The question is saying without. Then on the other question now, they are saying on 1.3, solve for x now. Now they want you to solve that equation. So my question is, they're asking you guys to solve this equation. Are you going to start here? Are you going to start here? And start again expanding this, to remove the fractions, this and that? No. Guys, as we have been working this equation, it is the same equation that gave us this nature of roots. It is the same equation that we simplified up to this stage here. It is already here. Here, this is where we are. So we are simply going to continue from there. It's a continuation, guys. Do not take this equation out to start. You still end up there. So it's a continuation, all right? So on 1.3, we now need to solve for what? For x. So we are starting here on our equation. 3x squared minus 5x minus 2 is equal to, that's an equation, this one, not an inequality. No, it's an equation. So remember, we have our quadratic formula as long we are given, guys. In this case, okay, they did not even specify to 2 decimal place or what, but we can apply the factorization because it was a perfect square. So in this case, even if you wanted to use factorization, but just for the sake of, we have been using the delta concept, which uses what? B squared minus 4AC. So I'm just going to continue with what? The quadratic formula, which states that x is equal to minus b plus or minus the square root of b squared minus 4ac everything over 2a. So in this case, our a, our b, our c are still the same as we had. They're still the same. And also another thing that you have to consider here is that if you are to check properly here, this b squared minus 4ac, remember what it represents. The b squared minus 4ac, remember that's our delta here, guys. B squared minus 4ac. We have already calculated the b squared minus 4ac here, where we got what? This 49. We have already calculated this part of b squared minus 4ac. So it is up to you guys. If you do not understand, just use your quadratic formula as usual. Substitute those values. But we have already calculated that delta, which is 49. So when substituting, understand that as well. So we're just going to take as x is equal to minus, what is our b? Our b is minus 5. That is our b. Plus or minus the square root of this part is the one that I'm explaining. The b squared minus 4ac. It is the one that we have already calculated here. So just take it, the answer there. We go to what there? 49. Yes, you can write, guys. I'm not saying it's wrong for you to simplify back to write the way that you are supposed to be in the usual manner. I'm not saying it's wrong. You can do that. 2 times a. So our a there is what? Our a is 3. So that's 2 times 3. So this is what we're going to have. So with this, guys, we can solve our equation. So just simplifying a minus to a minus, that's a plus. So that's 5 plus or minus the square root of 49. Yes, we can simplify. As we know, the square root of 49 is 7. But we can just leave it like that. 2 times 3, which is 6. So that is it, guys. Using our calculator at this stage, what were we going to obtain? That was going to put a fraction. 5, starting with a plus. That's plus the square root of 49, of which, guys, we could have just written a 7 there, no problem. So that was going to give us 2. All right. So our x in this case was going to be 2, or x is equal to what? So this time we're going to have a negative. In place of this positive, delete and put a negative. So that's minus 1 over 3. So that's the value of x that you're obtaining, minus 1 over 3. So that is the case, guys, that we are going to have at the end. So as we can see, we have solved this equation. We want to verify something because before we had to state or to determine the nature of roots without solving this equation. Now we have solved this equation. Is it exactly that? The nature of roots that we talked about here are the ones that we are having here. Like in terms of this description, let's go back to here, guys. Let's go back to our description and verify if it is exactly what we wrote here. We said from the same equation, without solving that equation, our roots, they are what? They are real, meaning to say we can obtain the roots, we can solve, we can, like, as you can see, these roots, they're there. Guys, to be non-real does not, it means does not exist. Square root of minus 3, that is non-real. So as long as you've got a number like this, to say it's 2, it's minus a third, it's real. So the first part is winning. This one. These roots, they are actually real. There we can have the roots. The second part, we say that our roots, they are what? They are rational. Are these two numbers rational numbers? Remember, a rational number can be written in the form of a over b. It's the same. The 2 over 1 minus 1 over 3, they can be written as fractions, a over b. The rational part is there. And unequal, are these roots unequal? This is 2, this is minus a third. As we can see, they are unequal. So it means what we described here on our nature of roots is exactly what we have. So guys, it's a test. Also, maybe you wrote a different thing here. Or maybe this is what we got. Then you are getting something else here which does not correspond to this one. Then it shows there's a mistake somewhere. So knowing this also is important to you guys. Under exam, you can also consider that, because maybe, guys, you know, you might have a mistake in your calculations. So to verify that one, it can be very useful. All right, let us consider another part of our question, which was now question 2 of this. So we just say question 2 of question 1 because, like, they just say like question 1 because there's another question 2 there. So I do not know, guys, how you were writing your test. So you're just gonna say question 2 of question 1, no problem. So let's move on to question 2. or number 2. Solve for x and y simultaneously. We were given these two equations, 7 marks for that. All right, no problem. Let us consider these two equations and see how we're supposed to attempt them. So without wasting time, guys, this is question 2 where we were given. All right, sorry for that. So we're given first part or the first equation, which was given as 2y plus 8 minus 8x is equal to 0. So we're just going to call this equation 1. And equation 2, it was given as 2x squared plus 4x, which is equal to y squared plus 6, which we're going to just call it equation 2. So as we can see, guys, we have a linear and a part of a quadratic, right? So with the linear equation, it's going to be easier for us to make x the subject or even y the subject. It's up to you. So, but especially y there, because as we can see, the coefficient of y there is smaller than this one. So we can use it as our highest common factor when we are dividing. At least that way it can make sense. But you can even work with x, but you get a fraction there. So to avoid working with fractions, that's why I'm saying choose the one with the smaller value. So from equation 1, well, let's make y the subject. Make y the subject of the formula. Okay, so that is the condition that we are going to have. So in this case, if we make y the subject, it simply means we are going to have 2y there is equal to, we take these terms to the other side of the equation. So it means 2y will be equal to what? All right, let's start with the x. Minus 8x to the other side is going to be what? Positive 8x. 8 to the other side is going to be what? A negative 8. So simply divide by 2 here. So that's the value, that's the y there as the subject. So 8 divided by 2, that is the condition that I was referring to. When you are dividing here, you are dividing by a smaller number. So you won't get what? Fractions when it is like this. 8 divided by 2, that's going to be what? 4. So you're going to have 4x, 8, and 2 again. That's a minus 4. So that's another equation that we have formulated from what? From equation 1. We have formulated this. So we are going to just call this our equation 3. All right. We made this from where? From equation 1. It was from equation 1. So what are we going to do is to substitute it into another equation, which is what? Equation 2. Not the one that you made the subject. You're going to substitute into the other equation. So substitute, just substitute here. All right, equation. So we're going to take equation 3 into 2. Into equation 2. So in place of y, wherever we see the y in equation 2, we are going to replace it with what? 4x minus 4. Wherever we see y, we're going to put 4x minus 4. All right, so let's do that, guys. This is easier now. So we're going to have this as what? 2x squared. We do not have y there, so it will just remain as it is. 2x squared plus the 4x, it also gonna remain as it is. We do not have y. We need, where we see the y, we put this one. So simply put 4x minus 4 in y. So like this one, on the other side of the equation, there is y squared. So in that place of y, we're gonna put 4x minus 4. So meaning to say it was going to be what? 4x minus 4 to the exponent of what? Of 2, to the power of 2. But there is a plus 6, which is separate. So take note of that. We're going to add the 6. We do not have y on this 6. It's just a constant. So just write as it is. So we have formed an equation, guys, which has only x. As we can see, it's only x that we have there. So we can solve for x. So expand the brackets, whatever that you're going to have, you solve for what? You solve for x. That is the case. Let's say we're just given an equation like this. They're saying solve for x. How are you going to solve? Definitely expansion of what? Brackets. So the left-hand side going to remain as it is. 2x plus 4x is equal to, we get rid of the brackets that we are given on the left-hand side. Guys, we can even use those identities. We can expand. Remember the a minus b concept. A minus b squared is equal to a squared minus 2ab plus b squared. So in our case, what is representing a? What is representing b? This is our a and this is our b. So using this concept, guys, we can easily expand because we need a squared, the first term, our a, b, the last term. So we need a squared, 4x squared. So what are you going to have? 4 squared, that is 16x squared. Everything will be raised to the exponent of 2. So our a squared was going to give us 16x squared minus 2ab. What does it mean? Minus 2 times our a is what? Our a is 4x times our b, which is what? Which is 4. So multiplying these guys, what are you going to have? Minus 2 times 4, which is minus 8 times 4, which is what? Negative 32. You're going to get negative 32x. Negative 32x from minus 2ab. Then we move on to b squared. The last term squared, it's plus b squared. So you're supposed to add b squared. What is our b in this case? Remember, our b is 4. So 4 squared is what? 16. Guys, we have expanded this. We have expanded your brackets. But take note, there is what? A plus 6 that is there. So you can expand it that way, guys, or simply open 2 brackets there, expand them the way that you understand. We're still going to have the same thing. Remember, we can just have 2 brackets, the bracket of 4x minus 4, another bracket of 4x minus 4. You expand these brackets properly. So this is the case of our question, guys, right? Let us consider solving. Remember, want to solve for what? To solve for x here. Want to solve for x. So what are we going to do? We can even consider, let us just simplify the right-hand side of our equation. The left-hand side is okay. Just rewrite as it is. On the right-hand side, we're going to collect the like terms, 16 and what? And 6 there. That's 16x squared minus 32x. 16 plus 6, that is going to give us 22. Remember, we want to solve for x, and we have this as a quadratic equation. The highest exponent is 2. Remember, as we had before, our quadratic equation format does not change. Ax squared plus bx plus c is equal to 0. One of the given sides. One side must be equal to 0. So what are we going to do? It is in your hands, guys. You can work with bigger terms. As you can see, the bigger terms are on the right-hand side. So it is easier for just taking us this to the other side. And also, these ones, they are few on the left-hand side. So let's take them to the what? Right-hand side. So the 2x to the other side, this 2x squared was going to subtract 16x squared minus 2x squared. So that was going to give you 14. Remember, the purpose is for us to have what? As 0. So 0 is equal to 16 minus 2, which is 14. So in the same sense, the 4x to the other side of the equation was a positive. The moment it crosses the equal sign, will be a negative there. Affected with what? Minus 32x. So it is now a negative. So that's minus 4x. Minus 32 minus 4, that is going to give us minus 36. So we've got minus 36x. Already there is a 22 not affected by anything. So just write as it is. So this is what we wanted, guys. Just to have a 0. We just want to have one side. Guys, whether it is the left-hand side or right-hand side, we do not care. As long one side is equal to 0. And also remember, guys, writing that this one is equal to this is the same as this is equal to what? Is equal to 0. The whole side here, this is what I'm trying to say. Our right-hand side is equal to what? To 0. That is what it means. It simply means 14x squared, as you see it like this, minus 36x plus 22 is equal to 0. A is equal to B, therefore B is equal to A. It's just one and the same thing. So we can choose to reduce this equation considering the highest common factor between these numbers, 14, that's going to be 2 there, guys. All right, by 2, by 2, by 2, each and every term. So that's 7x squared, 2, and this one, that's minus 18. Minus 18x, 22, and 2 was going to give us what? 11, which is equal to 0. So we have this equation, guys. We can use our quadratic formula. It is up to you. We can use our factorization, but as we are working with simultaneous equation, there's no way that they are going to give you equations which will lead to decimals that you will end up having your answers to 2 decimal place 1. You are going to be having exact values. Yes, they can be like that, but those numbers can be expressed as fractions, meaning to say they are rational numbers. Remember, rational numbers, yes, they can be endless decimals that we'll be having, but we can have a condition that they will be recurring. All right, those ones, they can be what? Written as rational numbers. So in our case, I'm saying you can use a quadratic formula. It's up to you. But in most cases, definitely your factorization is going to work. Because we are used to the quadratic formula, I'm not going to focus on that one. I want you to do the quadratic formula. Then here, let us focus on the factorization for the sake of revision. So for the sake of revision, guys, remember your factorization method, because you can be given a question like this where they actually need you to use factorization. So how are you going to factorize this? All right. Remember, you're going to have 2 brackets at the end. All right. The coefficient of x squared is not 1. That's a 7. So using the cheat method, I said we can take the 7 to this 11. We remove that 7 so that the coefficient becomes 1. So we're going to multiply that 7 here. So we have removed this 7. So it is x squared minus 18x plus 11 times 7, which is 77. Now, as you can see, the coefficient of x squared is 1. So it is easier for us to simply consider that condition of our brackets where we're going to just put x here and we put x here. Then we ask ourselves to say, what is a product? Actually, what are the products here of 77? But they must add up to what? Negative 18. 2 numbers, guys. You take 2 numbers. You multiply 2 numbers, you get 77. But adding these 2 numbers, you must get a negative 18. There is something about 11 and a 7. But to get this negative 18, what can we do? Negative, negative. Multiply these 2 numbers. We are going to get a positive 77. If we add these 2 numbers, we're going to get what? Negative 18. So that's exactly what we want. A minus 11 and a minus 7. So we're going to have minus 11 minus 7. All right. Remember, these brackets are not of our answer. They are from something that we created. So we must bring back the 7 that we stole. Remember, there we stole that 7. So let us bring back the 7 that we had to cheat with. We bring back in terms where the x is, we put the 7. Where the x is, you put a 7. Where the x is, you put a 7. Then I said you can factor out where you have got a common bracket. As long there's something common in that bracket. The first one, nothing is common. But in the second bracket, we can factor out the 7. All right. So as we are going to factor out the 7, it was going to give us what? X minus 1. This one was going to remain as it is, guys, as 7x minus what? 11. So what do we do with the 7 that we factored out? It becomes useless. So our brackets are these two. These are the ones that are waiting here. So I do not know with your method of factorization, the way that you understand. But at the end, what we are going to have, guys, must be the same. So use whatever way that you understand there. If you are using your factorization, if you are using this method, the one that I described as the cheat method, a simpler way, or guys, what can we say? We cannot say a simpler way because you might have a simpler way. To me, this might be simpler. To someone, this might be simpler. So using this method, you can end up like this. All right. So for x, from where the two brackets that we are given, one of these must be equal to 0 each. So we're going to have 7x minus 11 is equal to 0, or the other part of what? X minus 1 must be equal to 0. So we can solve for x when it is like that. The minus 11 to the other side was going to be positive. So 7x definitely is equal to 11. You divide by 7, guys. All right. So this one, no problem. Or x is equal to what? Positive 1. So if we take the negative to the other side, it was going to give us a positive. So these are the values of x. X is going to be this, or x is going to be this. But remember, we are dealing with what? A simultaneous, an equation which is supposed to be solved simultaneous, where we are solving for x and y at the same time. So to find the y values, it is best for us to substitute into equation 3. Yes, we can go back there and substitute in equation 1, whatever that you want. But it is best for you to substitute in equation 3, where we have already made y the subject of the formula. Remember, from this equation 3, y is equal to what? 4x minus 4. So taking that into consideration, which is our equation 3. So from equation 3, or substitute into equation 3. From equation 3, we had y is equal to 4x minus 4. So we're going to substitute into this equation to obtain the y values for each x value. When x is what? 11 over 7, y is going to be what? In place of x, put that, so that is going to be 4 into 11 over 7 like this, minus 4. So that was going to give us the value of y. You can just use your calculator there. So that's 4, open bracket, 11 over 7. So that's 11 over 7, close bracket, minus a 4. So this was going to give us 16 over 11. So we've got 16 over 7, not 11 there. All right, over 7. So that is what we're going to have there, 16 over 7. So we do the same thing for the y value that we are having, which is what? For x is 1, we substitute. There y is equal to 4 into what? Into 1 in place of x, minus a 4. So that was going to give us the value of y, guys. As you can see, we are just substituting in place of x here. We are simply going to put a 1 like this. So that is the y value was going to give us a 0. So we are done. That is the condition solving these equations simultaneously. For the x value, we obtain the y value corresponding. For this x value, we obtain the y value corresponding. So that is it. You can even write as points, like some of you guys want to write as point. Therefore, you're going to have, remember, a point written in terms of x and y. So our x is what? 11 over 7, where our y is 16 over 7. So you can have it like that. And another part where x is what? Where x is 1, y there is what? When x is 1, our y is a 0 there. You can have it like that. It is up to you the way that you understand your final presentation. Any part does not even affect at all. This part does not even affect at all. So this is it, guys, on your simultaneous equations. Make sure that you consider your questions properly, understand your equations. One of the equations, simply work with one, make either x or y the subject, substitute into the other one. Then we can solve for whatever that will be formulated there. Is it x? Is it y that you have formulated? That is the case. Then for the values of x or y that you have calculated, substitute them into the linear equation that you have formulated. That is the case. All right, so let us consider another part still on this question one, which we are saying one of three now. So part three, the roots of a quadratic equation, we are told they are from where? A quadratic equation. The roots of a quadratic, they are from a quadratic equation, these ones. These are given as determine the value or values of A for which the roots will be equal. For which these roots will be equal. All right, let's have our given question there, which is, like I said, part three now of question one. So no problem, guys. If you are to consider properly there, you're going to see that from the given equation, which is our quadratic equation that we are not even told about, we were solving it. We were solving that. Then the roots were given like this. The part of the roots, remember, when you are solving, all right, sorry, when you are solving your quadratic equation, minus bx is equal to minus b plus or minus the square root of what? B squared minus 4ac over 2a. So as you were solving, maybe at a condition like that, this is where you ended at this step, but it was written in terms of a, where you ended up with a 3 plus or minus the square root of what? Of 12 minus 3a squared. You were solving for x and you ended up with something like this. All right. So the 2a, someone might ask, what about the 2a? Where is it? It was just a number that was there. Then it was divided into this. Do not worry about that. What you're supposed to worry about in this question is the delta concept. Their presentation, guys, it's exam, they present the way that they feel like. In your presentation, focus with what? The delta, as long we are to deal with the roots. This part, the delta, b squared minus 4ac. This is the part that is going to answer our question. According to our question, we can see it. We can see that delta, that our delta is what? Is 12 minus 3a squared. Before we even answer the question, which is to say that these roots will be what? Will be equal. Are we understanding this concept? So this is our delta. Then they are saying we are supposed to find the value of values of a for which these roots will be what? Will be equal. From our nature of roots, the only part where the roots will be equal is where we are dealing with our delta being equal to 0. Remember, I talked about that on the first question that we had applied nature of roots. When it is equal to 0, there our roots will be what? Equal. So that's the only condition that we can have. Our delta must be equal to 0. For what? For equal roots. For equal roots. So meaning to say this delta as we see it, this equation, this part of our delta, this expression, the 12 as it is, this part of our expression 12 minus 3a squared, it must be equal to what? It must be equal to 0. Thus, you have formed an equation from this statement. From this statement, guys, we have formed an equation. Our delta must be what? 0. For us to have this rule, the discriminant must be equal to 0. So let us solve what? For a, because we have an equation. Once we say this is equal to this, We can solve for A. So the question is, how can we solve? So many ways that we can apply. We can factorize in this case. So we can even avoid that factorization. Like I said, there are so many ways. So let me start with this one. I can take this because the constant. So I can take it to the other side of the equation. So I'm going to have minus 3a squared is equal to 12 to the other side was going to give us minus 12. So dividing by minus 3, since we've got a product, divide by minus 3 here. So it means our a squared is equal to what? This one it was going to give us a 4. All right, so that's a squared is equal to 4. A squared, not a, but a squared. So what about a? You introduce the square root to get rid of that square. So knowing that the square root of any number is a plus or minus, so our a will be equal to plus or minus 2, square root of 4. So that's why we've got two values there. 2 or what? Minus 2. We could have solved it that way. Or in the same sense or same manner of solving for a, guys, we could have applied this concept that from this equation that we have, we can factorize. It can be factorized. This is equal to 0. We can factor out 3. In this case, is the highest common factor so far between 3 and 12. So factoring out 3, 12 divided by 3, that's going to be 4. Minus 3a squared divided by 3, that's minus a squared, which is equal to 0. So from this part, as we do understand, guys, one of these brackets must be equal to 0, of which the 3 is just a constant. So it can even cancel. And we have 4 minus a squared is equal to 0. 0 divided by 3, that's a 0. So the 3 does not affect. We do not even have x there. All right. So what about here where we are? We have a difference of 2 squares. Remember a squared minus b squared concept. This is what we have. So from our difference of 2 squares, guys, we can simply apply this because this 4 is same as what? 2 squared. 2 squared minus a squared. The square root of 4 is what? Is 2. So from our difference of 2 squares, it's going to be 2 minus a. Another bracket, 2 plus a, which is equal to 0. So that is what you're going to have from the zero concept. The zero concept, the product of these two brackets to give us a 0. It means one of these must be equal to 0. 2 minus a must be equal to 0, or this bracket of 2 plus a must be equal to 0. So what will be the values of a in that case? All right. So as you consider, we can avoid working with a negative. It's up to you. You can leave it like that. It's up to you. Minus a is equal to 2 to this side will be minus 2. Divide by negative, guys. So our a will be what? A positive 2. Or taking 2 to the other side, that means our a is going to be what? To the other side, it will be a negative 2. So these are the possible values of a that we are going to have for us to have equal roots. Our a can be positive 2 or a negative 2. Same thing that we obtained, plus or minus 2. This is what we are having. So you could have solved this, but as you can see, guys, this way we're going to have like a lot of things. But if you understand this way, then use it. If you understand solving this part of the equation from here, this way, then use it again. So that was it, guys. Let us consider the other part of our question, which was in this case on question or part 4, prove that the roots of this equation are rational for all values of b. They are rational. Remember the condition of your rational roots. All right. What is the condition for rational roots, guys? What is it that we must consider if the roots are rational? Let's start by that part of being rational. All right. We were given our equation here as 2x squared minus 2b minus 1 like this into x. That's equal to 0. Then they are saying we are supposed to prove that these roots, they are rational. From our introduction, guys, as I explained on the introduction, that the rational is considered when our discriminant, our delta, is equal to 0. There we have got the rational roots. But what is important there is that also these roots will be what? Equal. But when we have a condition when our delta or this discriminant is greater than 0, where it is equal to a perfect square, whenever it can give us a perfect square, I said also there, our roots, they are rational. Only that they are not equal, but they are what? Rational. So when you are given, guys, to prove this one, these are the two conditions that you're supposed to work on. Either this. So prove that if you calculate your delta, you're going to obtain a 0 or a perfect square. One of these conditions must emerge. Not to say we must obtain both, but one of these must emerge as we are solving for this one. All right. So guys, this is the condition. Let us simply find our delta. Remember, our delta is equal to what? B squared minus 4AC, our discriminant. All right. In this case, our equation is already in the format that we need of ax squared plus bx plus c. We have the part of here x squared. The coefficient of x squared is what? That is our a. We have it there. That is our a. Because as we can see, guys, in this case, one side must be equal to 0. Right? Exactly what we have in our equation. Why is my 0 there? To left. It must be 0 there. So our a automatically, we have it 2, the coefficient of x squared. What about b? The coefficient of what? Of x. What is multiplying x? The whole of this part here. It's a constant, guys. As long you see b there, the b, it's a constant. So do not worry about that b that you see. The whole of this part here that we see, it represents the b of the quadratic formula. So our b, the one that we need there, is the one that is given. This whole part minus into what? 2b minus 1, the coefficient of x. What about c? The constant. Do we have the constant? No, the constant is not there. So it means the constant was a 0. The number, if it is not given, if it is not written, thus we have got what? We have got a 0 there. So this is our condition. There's a 0. So let's calculate, guys. When the question is saying, here you are not told, guys, to say, what can we say? Like determine the nature. No. They are already telling you that those roots that you have, if they were to be solved, they are already rational. We are not determining the nature. We are supposed to prove. So whenever you're asked to prove, calculate as usual. As the way that you're supposed to have your discriminant, your delta. Calculate as usual. How are you going to have it? You're going to use this formula, isn't it? So you substitute there. B squared. What is our B? This is our B, remember? As we can see it here. So we substitute that as it is. But as you can see, guys, there's also a bracket there. So let me have another bracket like this. So it's going to be minus 2b minus 1 like this. This is squared. B squared. B squared. This is what we have. B squared. This one, the whole of this party, it is representing what? Our B. That's our B squared. All right. Minus 4AC, that's 4 times A. Our A is what? Our A is 2. And our C is what? Our C is a 0. So this is what we have. So as we can see, guys, simplifying this, here we're going to have a 0, guys. As long you're multiplying by 0, there's nothing there. So we're going to be left with this part. All right. A negative is out of the bracket, so you can raise it to the exponent of 2. Remember, a negative raised to the exponent of 2 gives us a positive. So it was just going to remain as 2b minus 1 to the exponent of 2. The negative is raised to the exponent of 2, this one. So we just remain with this bracket to the exponent of 2. Are we supposed to expand this bracket so that we see that it is going to give us a 0 or it is going to give us a perfect square. No, guys. Already we can see it from here, guys. A perfect square. What is a perfect square? Those are the numbers, examples of these numbers. 2 squared. It's a perfect square. Remember, 2 squared is what? It's 4. So if 4 is a perfect square, it means 2 squared is a perfect square if a number can be raised to an even exponent. 2 to the exponent of 2, 4 to the exponent of 2, 3 to the exponent of 2. So even in algebraic expressions like this, an algebraic expression raised to the exponent of 2 represents a perfect square expression. It's a perfect square. It's a perfect square, that one. So meaning to say there's no need for you to expand there. You already have a perfect square. This is what we want. Guys, for you to prove one of these conditions, like I said, must what? Emerge. And of these conditions, we are having this one of what? A perfect square. So as we can see that our delta in this case is a perfect square, right? Let me write our delta as it is so that we do not confuse this one. Our delta, 2b minus 1 squared is a perfect square. Is a perfect square. Guys, there is no way that you can say a number is a perfect square, then that number is less than 0. There's no way, guys. Definitely, or therefore, we are talking about our delta being greater than 0. It is bigger than 0. But being a perfect square, we are not worried about being greater than 0. We are worried about here being a perfect square. What is that we're going to get from there? Therefore, the roots are what? Rational. Therefore, the roots are rational. This one of being greater than 0, it is just telling us that the roots will be what? Real, rational, and unequal. But in our case, we are not proving all those. We want to prove here of being rational. So to prove being rational, it's one of these two. Delta equal to 0 or a perfect square. Just like that. So we have proved, guys, because we saw that it's a perfect square. So I talked about this, some questions where we proved. So sometimes you might not have it direct like this. This one, it was just like it is going direct to the answer. You don't even need to simplify anything. It is already on the point. All right, no problem, guys. Let us consider another part, which was now on question number 5, and that's 5.1. Solve this equation for x. So for x, we are given this equation. All right, let us consider the equation that we are given there and how to solve this equation, which is on question 5, and that's being 5.1. We are given x minus 3 is equal to 4 over x minus 3. That's our equation. What type of an equation? We do not even know. Is it quadratic? Is it linear? Is it what? We have to expand until we are left with a normal part of our equations, whether it's going to be linear, quadratic, we do not. But what is that we can do? There are two fractions here that we are given. X minus 3, it's a fraction. Why? Because it can be written as over 1. So we can choose to cross multiply to remove these fractions. Simply cross multiply. All right? We're going to simply cross multiply there. So cross multiplying, this is going to multiply this, and this is going to multiply this. So the x minus 3 is multiplying another x minus 3. What does it mean? Just like what we had, 2 squared, 2 times 2, 3 squared, 3 times 3. So a bracket and a bracket can also be written as a bracket squared. It's possible. So 1 times 4 is going to give us what? A 4. So this is where we are. Without expanding brackets, this equation can be solved by removing the square that we see there. How do we get rid of the square? Remember, guys, we were dealing with equations under sets. the square root of 3x plus 1 is equal to x plus 1, whatever that you have, then you remove the square root by squaring to remove or to get rid of the square root. You were putting the square. Guys, what is the opposite now? Because now you have a square. So if you remove the square root by putting a square, how do you remove a square? The opposite is true. Very true. You introduce the square root this time. Opposite is true. You introduce the square root. A square root and a square, in actual sense, guys, they neutralize. A square root and a square neutralizes, just remain with x. So once we put this square root, it is an equation supposed to be done both sides. But the purpose is to get rid of what? The square. To neutralizes this. So you're going to have x minus 3 is equal to what? The square root of 4, which is plus or minus 2. Remember, we talked about the square root of any number, plus or minus. So that was the case. So with this condition, we can solve for x because as we can see, guys, there are two values there. So as we take our minus 3 to the other side of the equation, we must note that it's going to be affected by two values. There is plus or minus 2 there. Plus or minus 2. So minus 3 to the other side is going to be what? Plus 3. There was what? A plus or minus 2 here. There was a plus or minus 2. So each number or each term of x is going to carry this, is going to be affected. Like one is going to take a plus, another one a minus. It affects the values of x at the end, knowing that. So there's a plus 2, plus 3. So let's start with the plus, this one. There's a plus here. So we're starting with that one. The 2, but is being added. 3 is just having a plus. 3 is not affected, all right? So that's plus 2 and what? And 3. Or our x is going to be what? We take when it is a negative this time. When it is a negative, when the 2 there is having a negative, remember it's plus or minus. Minus 2 plus 3, just like that. So this is what you're going to have, guys. Two possible values we're going to image here. 2 plus 3, which is 5, or x is equal to minus 2 plus 3, which is what? Which is 1. Or you can expand properly here. You can expand the brackets, all right? Let's do another way. Expanding this, we could have expanded. Remember, we introduced the square root to get rid of the square, to get rid of that square, to say, okay, we want to remove this square. But let's say we want to have another way. All right, we could have actually done that. All right, let us just, sorry for that. Another way that we could have used, it is x minus 3 squared is equal to 4. Remember, this is where we are. We were going to simply expand, remove brackets. So you expand, and to expand, guys, you can have two brackets, x minus 3, x minus 3. Or you can use that concept, guys, that I explained, a minus b squared is equal to what? A squared minus 2ab plus what? Plus b squared. Is the easier way, guys. You can see your a, as long you can see that this is my a, the first term, this is my b. You are done. You are done. Because you're going to have what? So you need to know this. A squared is what? This is a, this is b. So it's going to be x squared. Minus 2ab, minus 2 times our a. Our a is x. Our b is what? Is 3. So multiplying this is going to be minus 6x. Plus b squared, our b is what? 3. So 3 squared is what? 9. Just like that. Or you can expand properly two brackets. You can expand properly two brackets that you'll be given the bracket of what? X minus 3 and x minus 3. So x to x, that was going to be x squared. X to minus 3, minus 3x. We are done with x. You move on to minus 3. Minus 3 and x, minus 3x. Minus 3 and minus 3. That's a positive 9. You're multiplying there. So collecting your like terms here, what were we going to have? A minus 6x plus what? Plus 9. So this is it. exactly what we are seeing here on our left-hand side. So issue of solving, guys, it's in your hands. But from there, as you can see, we're going to have the same thing. Now let us solve. But as you can see, guys, we cannot solve because of these four. Let us take it to the other side of our equation. So what are we going to have there? If we are to take this to the other side, it's going to be x squared minus 6x plus 9 minus 4 is equal to 0. That's x squared minus 6x. 9 minus 4, that's a 5. And that's equal to 0 in that case. All right. So meaning to say we can solve this equation by applying our factorization concept. All right. Using our factorization there, we're gonna have two brackets that's equal to 0. So considering, guys, our constant, which is what? A positive 5. What are the products that will give us what? A negative 6 if we combine them, if we add those two numbers. We have a positive 5. What are the factors? We are considering factors. All right. So as you can see, there's a 6, a negative. There's something about a 5 and a 1. But if we add here, we're not going to get a negative 6. Negative. We need a negative there. So to have that, let's put negative, negative. Okay, let's multiply. Negative 5 times negative 1. We still get a positive 5. Let's add negative 5 plus negative 1. That was going to give us what? A negative 6. So this is exactly what we want. These two numbers, negative 5 and what? And negative 1. So that's x minus 5, x minus 1. All right, so that's it. That's the concept, guys. And from here, one of these brackets is equal to 0. So the minus 5 was simply going to give us a positive, or x is equal to the minus 1 to the other side was going to give us what? A positive at the end. So these are the values that we obtained previously without expanding. Without expanding, we got same values here. So this is your case, guys. It's up to you. All right. So that was our question there. That was our question. Let's see. 5.2 is a continuation actually here. Once you see the word hence, hence, this one. From there, continue from here. Solve for y. But do not just solve for y. In this equation, as we can see, guys, our equation, leaving your answers in said form. Your answer must be in said form. So the mark allocation is the one that I was just worried about. But anyways, let's see, guys. 5.2. This is what they are trying to say, guys. Hence, remember I said is what? It's a continuation. It's a continu. Once you understand that, you're done, guys. Hence, from what you've just calculated, from there, continue from there. All right, no problem. So on our 5.2, it's true that we are supposed to continue from what? From 5.1. But as we continue on 5.21, we are supposed to solve for what? We are supposed to solve for y, as we are given there. And our answers are supposed to be what? In said form. All right? We are supposed to solve for y, and our answers are supposed to be what? In said form, which is not a problem. In what? Said form. As we are solving for y and our answers being in said form, the equation, look, our equation, let's take our equation also. Our equation there is given as y squared minus y minus 3, which is equal to 4 over what? That's y squared minus y minus 3. So I want you to see something here. I want you to see something. They are saying hence, guys, meaning to say continue from here. So, guys, what are we supposed to continue? What are we supposed to take from that continuation? Because we just solved here the values of what? X. To say our X is what? 5 on O1. This is what we just had. How can we see that this one is going to be 5 or this one is going to be 1? Let's take the way that it was before. There is something here very, very familiar on this original equation, the way that it was. There's something very, very familiar there. All right, let's compare these two, the original equation and the one that we are being asked to solve here. Let's compare the two. All right, no problem. The original equation was given as x minus 3 is equal to 4 over x minus 3. Guys, there's something that we can properly see that is something that we can consider to say here according to our presentation. There is a 4 here. There is also a 4 here. The presentation here is the same. Here it's x minus 3. This one is also x minus 3. Are we seeing it? This one and this one are the same also. Exactly what we are seeing on this other presentation. So we can choose to substitute to say, if you want to separate further, guys, you can take it one by one because there's also a minus 3 here and a minus 3 here. So you can say a minus 3 here and also a minus 3 here. So what is remaining is equal to x. This one will be equal to x, which is the same as what we are seeing. It is the same thing. But as for me, guys, it's going to be something, there's like a lot of things that you're considering, that you're looking into there. If you see that this 4 and this 4, they're equal, guys, and we properly see the same thing here on x minus 3, x minus 3. This is the same thing, y squared, this part, whatever that we have there, y squared, this part. So therefore, we can conclude with our mathematical understanding that there is no way, guys. It is the same presentation that we have. So therefore, y squared minus y minus 3 must be equal to what? Must be exactly the same as x minus 3 from that case. Therefore, this part or this part, because it is the same thing. No matter you're talking about this or you're talking about this other one, y squared minus y minus 3 must be equal to this one, which is what? Which is x minus 3. Where they're talking about these guys, it is the same thing. These two, they must be equal. But we saw that now. If we are saying these two, they're equal, the only thing that we know here, guys, are the values of x. So that's where the hence part now is going to play a role. And there are two of them. So meaning to say we are going to form two equations from this statement. From this statement alone here, we are going to form two equations. So therefore, we are saying y squared minus y minus 3 is equal to, when our x is what? 5. When x is 5, we substitute a 5 in place of x. So that's 5 minus 3. We have an equation there. Or when this x is 1, all right? When x is what? Is 1, we substitute there. So it was going to be y squared minus y minus 3 is equal to, in place of this, x, you substitute a 1. So that's 1 minus 3. You have formed an equation in y only. There is y here, there is y there. So we can solve these two equations. It is in the quadratic equation, yes, but it's only about y there. Remember your quadratic equation concept. So y squared minus y minus 3 is equal to 5 minus 3, which is 2. On the other hand, y squared minus y minus 3 is equal to 1 minus 3, which is minus 2. Remember the format. One of the given sides must be equal to 0. So you're going to take the 2 to the other side. That is going to be what? A positive there. Sorry, a negative because it's positive. So it's going to be y squared minus y like this. There is a negative. It's going to be negative there. So it means it's minus 3 minus 2. So minus 3 minus 2, that's what? Minus 5, which is equal to 0. Or we solve this side. Again, just like the previous case, the minus 2 to the other side, this one was going to give us a positive 2. So meaning to say, guys, we're going to have y squared minus y there, minus 3 plus 2, which is minus 1. That's equal to 0. We have two equations. Very true that we have got two equations, but being quadratic equations at the same time, meaning to say the quadratic formula was supposed to be used as we have our quadratic formula in terms of x. We must also know that it can be used in terms of y. So not x is equal to only, no. It can also be written as y is equal to, as long as what? Quadratic, there's exponent there. So it can be written as y is equal to minus b, our quadratic formula. So that's minus b plus or minus the square root of b squared minus 4ac everything over 2a. It can be written like that. It can be written like that. So what is our a or b or c? Remember those coefficients. The coefficient of y squared, the coefficient of y here, the constant. So remember there are two equations. So we're going to solve this one, we solve that one. All right, so on the first one, guys, here, we're going to have y is equal to minus our b, the coefficient of y, which is what? Minus 1 plus or minus the square root of what? B squared minus 1 squared minus 4 times a. Our a is 1. Our c is what? Negative 5. Everything over 2 times a, which is 2 times 1. So y was going to give us negative, negative. That's a positive. Plus or minus the square root of what? You can just use our calculator to simplify what is under the square root. Open a bracket, minus 1 squared minus 4 times what? Times 1 times negative 5. So that's negative 5 like this. That was going to give us 21. So that's a 21 over what? 2 times 1, which is 2. Remember, the question is saying solve for y. But as you are solving for this y, your answers must be what? In said form under the square root. We must see the square root on our answers. So as we can see here, it is already in said form. That is that there's nothing that we can do here. It's already in said form. That was from the first quadratic equation, which was of y. There's another one, guys. Remember, we were saying y is equal to this from this quadratic, or there's another one there. So we're going to solve another part for y here using the same quadratic formula. So y is equal to what? Minus b. What is our b? Just like the previous case, guys, the coefficient of y squared, y, and so on and so on. So the coefficient of y there, that's our b, which is what? Negative 1. So that's a negative 1 plus or minus the square root of b squared minus 4ac. Our b, remember, that's our b there, which is what? Negative 1 squared minus 4 times our a, which is 1, and our c, which is what? Which is negative 1 like this. Everything over 2 times a, which is 2 times 1. So just like the previous case, you were simply going to evaluate and see what you're going to have: negative, negative, a positive, plus or minus. You simplify what is under the square root. Just like the previous case, you're going to obtain a 5 there. Everything over 2 times 1, which is 2. So that is the possible values of y that we have in what? In a said form. As we are given the instruction there in said form. In said form. So you must be careful, guys. Questions, you see, when it is, and the other thing that I just wanted to say also is, you see this question paper, guys, like the test that you guys were writing for those who wrote this one, the ones who requested for me to work on this question. You see, guys, even you guys who did not answer, who did not try this one. Guys, these are questions that has been taken, some of them textbook, some of them we can see that this just a question paper as it is. Textbook. Revise, guys. They're just repetitions. Repetitions throughout. So they are not going to take much from what is to say I have my own question that I'm going to work with, guys. Questions are being repeated now and again. Questions are being regenerated now and again. So the more you do more question papers, guys, the more you say, okay, this is the idea, this is that. They're being regenerated now and again. So do as many questions as you can. As many, guys, as many. For you to have the higher mark that you are aiming for. All right. On question number 6, without wasting time, we're given if x plus y minus 2 into x minus 4 minus y is equal to 0. Determine the sum. All right. There are two things here. All right. No problem. Determine the sum of what? X and y. Okay. If the difference between x and y is, all right, determine the sum of x and y. All right, let's see, guys. This is our question number 6. We want to figure out that statement that we are given on its own. What does it actually mean from what we are given there? They are saying we have an expression already. All right, let's start with the expression before we talk about the statement. This is what we are given. There are two brackets like this, and that's an equation. Actually, you can no longer say an expression because this whole part is equal to what? To 0. And the question needs us to determine the sum from this expression that we are saying. I mean, from this equation, because as we can see, guys, we have got what? An equal to 0 there. So the question was determine the sum of what? X and y. What is the sum? What is representing x plus y when we are given that if it's a statement that you're considering on its own, if the difference between x and that same y there that we are given on their sum, now they are giving their difference. Their difference is what? Is 5. They are telling you that the difference of these two, which is x minus y, as we had on the sum, but this time if you subtract x minus y, the difference is what? Is 5. It's a given statement that we must apply or use to find x plus y. So what does it mean, guys? It simply means wherever you see x minus y on this equation, you can substitute with a 5. So we have to locate for that x minus y. Where is that we see? The x plus y that we want, guys, we can see it here. The x plus y that we want is this one. This is what we want. The x plus y. What about what we are given? I mean, what we are given? We are given x minus y. And we can see it in the second bracket there. We have got an x and there is a minus y there. But they're just like separated to say the way of the presentation. So if you do not understand, guys, remember numbers can be rearranged or rewritten in the way that we want. So you can write this as x plus y minus 2. Then this one, we can start with our x followed by what? Followed by minus 1. Then we end with the minus 4. We are not transposing anything. There is no number that is closed the equal sign here. It is just rearranging the number with its sign, the term, the letter as it is. What we just want to is to properly see what is our x minus y here. This is the part that we want to properly see, the x minus y. Why? Because we have its equivalent whenever there is an x minus y. It is represented numerically by what? By a 5. That is what we are told. Numerically, it is represented by what? By a 5. So wherever we see that, so we're going to have x plus y minus 2 into what? In place of x minus y, substitute the 5 that you're given. So that's 5 minus 4 equal to 0. Just like that, we can solve this equation. 5 minus 4, that's a 1. And we do understand, guys, 1 times anything, any number That number remains as it is. 1 times 2, that's a 2. 1 times 3, that's a 3. So 1 times x is what? It's also x. So 1 times this bracket, it will remain as it is. X plus y minus 2 is equal to 0. Guys, we got rid of the bracket that we substituted because it was a 1. So 1 can multiply and just remain as it is. But we are saying this part of x plus y minus 2 is equal to 0. Is it what we are being asked? No. The question is we need to see exactly x plus y. This is our question. We need to exactly see this. What is its equivalent? So what is affecting on our question? It is the minus 2. So we need to solve for x plus y. So we take the minus 2 to the other side of our equation. All right. So that was going to be a positive there. So that's x plus y is equal to a negative 2 to that side was going to be a positive 2. So this is exactly what represents x plus y as a numerical value. X plus y can be written as what? As 2. Just like what we're given, x minus y can be written as what? As minus 5. As 5. Guys, under another consideration, they can even continue and say solve for x and y simultaneously. Why? Because you have linear equations. So you can simply take x minus y is equal to 5 and also x plus y is equal to 2. You solve those linear equations. So you must be careful, guys, in exam. But in our case, they did not say solve for that. They are just saying find an expression for x plus y. What represents what? X plus y is 2. We just need a numerical value in place of what? In place of an expression. This is the continuum for your question. They just want you to have a numerical value in place of this expression, this one. You must have what? A numerical value to replace x plus 5, x plus y. Just like that. Answer the question, guys, in exam. So you see, the mathematical part, guys, of exam is understanding of the question. Not just to say, okay, it's an equation, I've done equation, I've did these ones, a lot of them. No. What about the question? Are you understanding what is the question about? That's exam. So most of you, you'll be saying, I did equations, I did this, but this exam is like this. Yes, because of there is a way of exam, the way of asking of questions. So the more you do questions, guys, the more you do your question papers, the more you understand, you end up getting the mind of what? The examiner. You ending up getting the mind to say, okay, our examiner, they think like this. So even when you are studying questions, you are studying, textbook, okay, this one, they will ask about this type of a thing. That's the purpose. So do as many as you can. So you're going to have a continuation there on question 7. So they were just given, which is 7.1, is you to express in form of, or yeah, given the format there, the minus 2 into x plus m squared plus k. So the question is, what is this format here? Yes, we have got a quadratic expression, but the format there, where m and k are independent of what? Of x. We have our completing of the square method. Remember, it is the one that ends up with this when we are given that square, then added to a constant like that. So it was all about completing of the square method. All right. So remember your completing of the square method, guys. All right. So we also refer to that one as a separate topic. So by now, guys, we must have the basics of our completing of the square. So anyways, let's see, according to our question, how were we supposed to complete the square on this function in order for us to have the format that we are given? Remember, it was minus 2 into x plus m squared. All right, the format that you're given as it is, all right, plus a constant. So this is it. So from here, we are going to complete the square. As we have the completing of the square method, guys, remember the coefficient of x squared must be 1. So what can we do? This is not an equation where you divide by -2. No, it's an expression. If it was an equation where you are solving, that's where you can divide. But on an expression, I said you factor out. So we are going to factor out the -2, the coefficient of x squared, the one that we want to get rid of. So we factor that one out. So factor this one, we're going to have -2 and -2. That was going to cancel and get x squared. All right, we divide 3, divide by -2, that's -3 over 2x. -6 divided to -2, that is going to give us what? A +3. So you factor out, remember the concept of factorization. Then remember your steps. How do we obtain or simplify this? We need to have the coefficient of x. What is the coefficient of x, the number that is multiplying our x in this case, which is what? -3 over 2. So we are going to multiply that one. So we need half the coefficient of x squared. The square of half the coefficient of x. Square half the coefficient of x. So half of this one was going to give us negative 3 over 4. You can just even use your calculator there, squared, which was going to give us positive 9 over 16. So this is it, guys. You can have this one as it is, as 9 over 16, or you can replace this part. So as for me, I'm going to take this one. Remember, this square that we have, we are supposed to add and then subtract this square that we are talking about. We must add it and subtract into this expression. So it was going to give us -2 into x squared minus 3 over 2x. Here on this quadratic, we are going to add our square. So it's either this one or this one. So as for me, like I said, I'm going to use this. So we are going to add -3 over 4 squared like this. And at the same time, we must subtract that. All right, so that's a -3 over 4 squared. We add and subtract. But remember, there was what? A +3. So this is what you're going to have. All right, let me just have like a mother bracket here to represent the whole of this part affected like this. So this is what you're going to have. All right. So the purpose here is that we have a perfect square, and we said we're going to factorize this part of our quadratic expression, this first part here. And to factorize, because these are perfect square, guys, using the concept of a minus b squared or the a plus b squared of a perfect square, we have got a negative in this case. So it is going to be what? A minus b squared. So our a or x is what? Is our x there. So it's going to be x, then this part, -3 over 4 squared. So that's our a minus b squared. Take the first term, raise to the exponent of 2, and also your last term. The rest, I said, you simplify that. So this one, just take your calculator, simplify as it is. All right, so this is what we are going to have. There's a minus start here, there's a minus there. So there's a minus, you can just put a minus there. Open a bracket, then we have got -3 over 4. All right, so this is -3 over 4 squared plus what? Plus 3. So that was going to give us 39 over 16. The whole of this part simplified, that's a positive 39. So we're going to have positive 39 over 16 like this. All right, so this is where we are, guys. We have to expand the brackets, the major bracket, this one, outer bracket by what? By the -2. So the -2 is going to multiply here. The -2 is going to multiply here. So the first part, the -2 cannot multiply inside of the bracket. Take note, there's what? A squared there. So you just write it outside of what? Outside of the bracket. So it's going to be -2 into this bracket as it is, x minus 3 over 4 squared. The -2 is supposed to also multiply here. So there we can just use our calculator there. -2 times. It is supposed to multiply what? Positive 39 over 16. That's 39 over 16 like this, which is negative 39 over 8. So we're going to obtain negative 39 over 8. So this is where we are. We have completed the square. We are done. Is it the format that we are given? Exactly what we are given. We are supposed to have that format, guys, that we are given here. So the format that we are given is what? This one. -2 into this. Exactly what we can see here. The -2 into x plus m squared plus our k like this. This is the format that they are talking about. It does not mean that if this one here, yes, the -2 is a constant. It's a number that you are given. They already gave you a number, so it must be -2. But inside here, it does not mean when they say plus m, this one must be plus. No, it just can be negative. Even here plus a constant can be negative. All right. It means there is plus and a minus. So we don't write that because we want to match the plus that we see there, right? The negative as it is. So that was our question. The first part was to have it in this form. Then if you check here, it's a continuation. After that, find the values of m and k. After you've done that, find the values of m and k. So to find m and k, guys, we can simply use the format because already we are saying this format represents the same thing that we are having as here. So therefore, we can simply take to say our m is what? As it is corresponding, that's a negative there. So therefore, m is equal to -3 over 4. What about our k as it is? K is what? A constant. And our k is going to be what? Negative 39 over 8 as it is. So that was our question in this case, all right? Then we move on to the other part of the question, which is 7.2. Deduce the maximum value. What will be the maximum value of this? If we are dealing with this as a function, if we are taking it as a function, remember from the function, I want us to refer something here too. Say, was it supposed to be a maximum or not? Remember when we are given that f of x is equal to, as we are given there, it was negative 2x squared plus 3x minus 6. If we take it as a function, the coefficient of x squared is a negative. Our a here, our a is less than 0, a negative. Remember when it is like this, when I have what? A set shape like this. So meaning to say, truly, we are talking about a maximum. If it was a positive, it was going to be a smiley shape like this, which is what? A minimum value. For this one, we talk of what? A maximum value. So truly, our question as it is being asked, it is stating exactly the maximum. But they said they want the maximum and the corresponding what? And the corresponding value of x. So our maximum value, how are we going to have it? All right. So we know that after completing our square, the maximum value is simply the value of y that we are seeing as it is this one. The part of y as it is. That is our maximum value. So therefore, our maximum value is what? -39 over 8. At or when x is equal to what? At x is equal to the part of x, this one. You don't take as it is. You equate that one to 0 to find the x value there. So for x, you equate to 0 to say x minus 3 over 4 must be 0. So you take to the other side. So x must be what? 3 over 4. So x there is supposed to be positive 3 over 4 at the maximum value. The value of x is affected. Remember from the format of a a turning point like this one of completing of a square, depending, guys, with the textbook or the way that you're given, can be given as x plus b. They can give us the x. Here they can give us a b, depending with what you're given, guys. But any format that you can have, let's say here we are given x plus b squared, then there's a c here. It follows that at the turning point, our x will be minus b. This will be our turning point. So actually, the turning point, which represents the maximum value or minimum value, it will be at minus b versus c if you have got something like this. So as we can see, the part of x, when it is written from a positive, it is a negative. This is the condition that we are simply having. But the c remains as it is here. So the maximum value remains as it, but the part of x has to be affected. If it is a negative on your formula, you put as a positive. So you just introduce a negative. When it is a positive, it will be a negative. That is the condition for x. But for the maximum value, for the y value is not affected. You take the y value as it is. All right, considering another part, it is to solve for x given an inequality this time. All right, so let's see the inequality that we are given there, that we are supposed to solve for x. On question number 8, we are given that's 12x squared minus 4x. Then we also have another bracket of x squared plus 1, which is less than or equal to 0. So if we were to look into this inequality, we're going to see two things here. There is this part here, which is x squared plus 1. Guys, as long we are working with this type, we cannot factorize it. It cannot be simplified. And also another thing, x squared plus 1 for any value of x. Just think of any value of x. Whether x is a negative, whether x is a positive, just think of any value. The moment you put that value and square it, what's going to happen? A negative, when being squared, it gives us a positive. A positive, when you square it, it remains as a what? As a positive. So it means, guys, no matter that you have here, this must be positive. This must be positive. It cannot be less than 0. It cannot be. It must be always be positive, meaning to say it must be greater than 0. It must be bigger than 0. We cannot solve for that one. Even if we're to find critical values, let's say you want to find the critical values. Remember, you're going to factorize here. What about this one? You're going to say x squared plus 1 is equal to 0. X squared is equal to what? Minus 1. Square root to square root, you'll find that there are no solutions here. So as for our level, as for our syllabus, we do not work with complex numbers. For others, guys, they can solve these ones using complex numbers. But as for our syllabus, to what we are restricted to, we cannot evaluate further. So meaning to say, x squared plus 1, this one, cannot be even equal to 0. It cannot be less than, it is supposed to be a positive greater than 0. So you cannot find anything there. There's no solution as of this one. It only operates for values that are greater than 0. Positive. So here we cannot operate. So we take it out of our inequality. We are remaining with this part. So that one is the one that we are supposed to relate. This is the one that we are left with, that we are supposed to relate when it is less than or equal to 0. So that was the idea of your question, guys. So remember, finding of critical values, we can factorize this and that. All right, so let us factorize the highest common factor. That's 4x. 12x squared divided by 4x, that's 3x. Minus 4x divided by 4x, that's a minus 1. That's less than or equal to 0. All right, 12x squared over 4x. For this one, 3x squared, that's going to be what? 3x. All right, so that is the case. So if you are to consider there, we can determine our critical values from this concept we can have our critical values. Remember, one of these must be referred to 0. So in that case, x is going to be equal to 0 because we are saying 4x is equal to what? 4x is equal to 0. So dividing by 4, our x was going to be what? 0. Or other part of the critical value is going to be taken from the bracket of what? 3x minus 1. From this bracket, we are saying also it must be equal to 0. So let's solve. To the other side, that's a positive. So 3x is equal to what? A positive 1 divided by 3 by 3. It is equal to a positive 1. So we can divide by what? By 3. So that's determining the x value, which is our x was going to be equivalent to 1 over 3. So we have the critical values that we are going to use now to determine the solution. Remember, here you can use, is it number line? It's up to you guys. You can use the number line. I want you to use that. You can use the graphical method. As for me, I'm just going to use the graphical method, guys. As we can see here we are taking it from here. Remember, this is the one that we are solving. This one we failed. There's nothing there. So we are solving this part. On this part, our a, the coefficient of x squared is 12. So a is greater than 0. So meaning to say we're going to have what? A smiley shape on our function. But this function is what? Less than 0, meaning to say we need where this function is what? Negative. Our function is a smiley shape, but where it is what? Negative. So that is the consideration. If you're using the graphical method, number line, guys, it's easier. You can just use your values there and so on. So this is our graphical method, guys. I'm just going to use x0 there. So I'm just going to take it. 0 is on the origin there. That's why I had to present. But even, guys, it does not even matter. Even if you don't put this, guys, you just draw this line and you put like this. As long you understand what you're doing, guys, to say, this is my x-axis, this one. It is your x-axis. So there is a 0, there is a third. Which one is bigger? Which one is small? 0 is small, so it's going to be on the left side. The bigger value on the what? On the right side. Does not mean you're supposed to indicate that vertical line of our y-axis. No, it does not even affect. So this is our f of x. Where is that our f of x is a negative? Remember, positive, negative, positive. Where it is negative, below the x-axis. Where it is what? A negative. So in between 0 and what? A third. So how do we take this solution? It follows that therefore our x is supposed to be a value bigger than 0, but less than what? Less than a third. Then we look into our question. Were we having an equal to? Yes, there was an equal to here. There was an equal to. So our answer also must have that equal to, as we had it on our question. So that is our final solution, guys, that we can have. So just keep on revising as many questions as you can, guys. That is the major part. So for this one, 4 marks was enough. All right. Let's look at another part of this question, which was now question 2, having its subsection like this. These were the questions that were given on 1.11. Okay, question 2, but okay, so it's question 2, but question 1 under that. No problem. I'm just going to use that denotation, guys, that we are given so that we do not confuse each other on that part. So it is just written as 1.11, which is solve for x, and we're given x minus 2 into 3x minus 7, that's equal to 0. So guys, already they factorized for you here. Just take the 0 concept. 1 must be equal to 0. So either x minus 2 must be equal to 0, or this 3x minus 7 must be equal to 0. So let's solve for x. To the other side, that's a positive. All right. Or our x is going to be what? To the other side, that was going to be a positive 7, but there's a 3 there that you must divide with. So that will be 7 over 3. All right, just like that, guys, you have got your 2 marks. Then 1.12, this one correct to 2 decimal places, 4 marks. All right, let's consider what you're given on 1.12. our equation was given as x squared minus 5x is equal to 2. X squared minus 5x is equal to 2, like this. Sorry for that. So how can we solve? It's a quadratic equation, very true. So we need its format. Remember, ax squared plus bx plus c is equal to 0. One side must be equal to 0. So you have to take the 2 to the other side. X squared minus 5x, 2 to the other side was going to be what? A negative. So that our quadratic formula can be used. Since they said to 2 decimal places, we cannot even concentrate with our factorization when it is like this, guys. Once they refer as 2 decimal places, what? They straight to the what? Go straight to the use of your quadratic formula. Remembering our quadratic formula. So remember that our quadratic formula is going to say x is equal to, I'm going to write this formula, guys. I don't know how many times, but you need to know your formula. You need to know your formula. In as much as you're answering, write down your formula, whether you wrote it before or not. Write it down. The coefficient of x squared, that's our a, that's our b, and that's our c. So let's substitute. So x is equal to minus our b is what? The coefficient of x. That's a negative 5 plus or minus the square root of what? B squared. Our b is what? Negative 5. So that's negative 5 squared, negative 4 times a, the coefficient of x, times c, which is what? Which is negative 2. Everything over 2 times a, which is 2 times 1. So that's it with this part, guys. We can simplify in as much as we can. So x is equal to minus, that's a positive, plus or minus the square root of here. We just need our calculator. So let's use our calculator there. Negative 5 squared minus 4 times 1 times negative 2, like this. So that was going to give us what? 33. So we have got 33, everything over what? 2 times 1, which is 2. All right, so that is the case of our question here. This is where we are. We can separate this on our calculator, guys. Solving this, we can separate so that we have our answers as we are given. They say to 2 decimal place. We can even fix our calculator. Let's just fix it. Shift, then setup, fix this 6, then 2 decimal place, press 2. All right, so that's, you have 5 plus the square root of 33, everything over 2. So then convert here, that's 5,37. So we've got 5,37, or x is equal to, same, just gonna put a negative here, delete this one, put a negative, then convert. That's negative what? 0,37. Negative 0,37. So this is it. We have our x values to 2 decimal places as per instruction of our question. So the major part here was just rewriting in the basic format. Then from there, you can use your quadratic formula as what? As usual. All right, let us consider another part of our question, which is 1.13. Again, we've got an equation there, 4 marks. All right, why 4 marks on this one? It seems like it's very, very common equation that we are given. But anyways, let us see what we are given. This is 1.13. So our equation is the square root of what? The square root of x minus 3. Then this one is not under the square root, is separate. Minus 4 is equal to 5. So guys, check, guys, we do not have any x that is there. So remember, we are dealing with a set. Isolate. Make sure that the set is on its own. So the square root of x minus 3 is equal to what? We take the negative to the other side of the equation. So that was going to be what? A positive 4. Or simply add both sides. So that was going to give us what? 5 plus 4, that's 9. To remove this square root, we square. Remember the opposite, square. So you're going to square both sides. To square, remember the purpose is to get rid of what? The square root. So you'll be left with what is under the square root, x minus 3, which is equal to 9 squared, which is 81, 9 times 9. So guys, this was a direct equation. We can solve the minus 3 to the other side or just add the 3 both sides like this. We have got our x value. So our x was going to be 81 plus 3, which is what? 84. You can even test, but here, guys, it's just a direct value. Let us just put our calculator. Okay, let me go back to the normal mode so that we can see if what we have on the left-hand side, the square root of our x, remember it's 84. So that's 84 minus 3. Then we move aside. We are supposed to subtract 4. By doing this, we are supposed to get what? A 5. And that's exactly what we are having. So this is true. So that's the true value that we just calculated on this part. All right, let's consider another part, an inequality again on this 1.14. So let's consider that's an inequality again, 1.14. We are given 2x squared minus 7x minus 4 is greater than or equal to 0. So as we have our inequalities, we need the critical values. So we're going to need to solve. But here the coefficient of x squared is not 1. So the factorization part that we were going to have was going to be in our hands, guys, the way that you understand your factorization. So I'm just going to also continue with our cheat method. 2x squared minus 7x minus 4. So remember our cheat method, we're going to cheat this one, steal it, throw it away to multiply to what? To this 4 that we are given. So it means we'll be left with what? X squared. So x squared minus 7x minus 4 times 2, which is 8. So as we can see, the coefficient of x squared now is 1. So we can use the basic approach that we are used to x and x here. What are the factors of what? Negative 8. But these factors must add up to negative 7, the product of negative 8. So that's negative 8 and 1, 8 and negative 1 like this. But which one of these two is going to give us a negative 7? Because if we multiply these two, if we multiply, we'll get a negative 8. But when we add now, when we add the minus 7, minus 8 plus 1. Minus 8 plus 1, it's what? Minus 7. 8 plus minus 1 is what? A positive 7. You can even use your calculator. So we see these conditions, they gave us a negative 8 in multiplication as factors. But when we added, the part that gives us a negative 7 here is what? Minus 8 and positive 1. So this is the part that we need. So that is the part that we're going to take. We have a minus 8 and a positive 1. A positive 1. Remember, it was from these two brackets and it's a cheat method. So we must bring back that 2 that we stole before. So in place of x, we bring it. In place of x, we bring it. We factor out anything common in these brackets. The 2 is common in the first bracket. So that's 2 into 2x and 2, that's x, minus 4 and 2, that's minus 4 into what? Here, there's nothing common there. So it's just 2x plus 1. So this is the consideration of our question. As we can see, the 2 that we factored out, I said it becomes useless into our question. And whatever that we're having, the 2 that we factored out, you can get rid of it. It's no longer part for question. This is what we want, these brackets. So we're going to have x minus 4, another bracket, 2x plus 1, just like that. So how to have these brackets? Guys, that one is in your hands. I don't know. I don't know. Which method are you capable of? Are you using this one? If you're together, let me know if you have any other method, guys. That's the purpose of the comment section. Let's communicate so that we also consider those methods in other classes. So as we have this part, the major part was to determine the critical values. So therefore, our critical values can be determined as each bracket will be equated to 0. As you take this one to be equal to 0, or as you take the 2x plus 1 to be equal to 0. Those are the critical values. So the minus is going to be a positive on the other side. So that's a positive 4. Or this part x is going to be what? 1 to the other side was going to be negative 1. Then definitely you're going to divide by the 2 there, which is multiplying. So these are the critical values. Using the graphical method, we can see that the coefficient of x squared, which is our a, is greater than 0. That's a 2. So you're going to have a smiley shape. And for which values greater than or equal to 0, for all positive values, that is according to this. For all positive values, or you can use the number line, guys. I explained all of these methods, so it's up to you which one are you going to take. So I'm going to use just graphical. So as you can see, it's a smiley shape. So we're going to have it this way. The minimum value minus half. So minus half is on this side. The bigger value is on this side. So we need where this function is what? Positive above the x-axis. Remember that it is what? Positive above our x-axis. It will be what? Positive. So that's positive, positive. Below the x-axis here, it's what? It's a negative. As we are focused where it is on top, this side. So which values are these ones? Which values are these ones? X is smaller than this. On this side, minus half, minus 1, minus 2. All these values, they will be less than what? They will be less than minus half. So therefore, our x is less than or equal to minus half. Remember, there is an equal to on our question, or our x is what? On the other side for these values, 4 going up, 5, 6, 7, 8. They are bigger than 4, but also equal because of what? Our question, there is an equal. So that's greater than or equal to 4. So that is the condition of our question. Let's do answer as many as we can. As many as we can. On this other part, solve the following equations simultaneously. All right, so as we are to consider that simultaneous equation that we are given, if you are to consider it properly, you were going to notice that already there's something that we are already given as the subject of the formula, our x. X is equal to what? That's 2y plus 1. That's our equation 1. And our other equation was x squared minus 2y like this plus 3xy is equal to 6. So as I said, guys, the first one is already, x is the subject there. X is the subject. X is already written in terms of what? So x is equal to this. So there is no need of us making another x the subject. From where? Already it is the subject. So simply substitute your equation 1 in 2. That was our case in this question. So where we see the x, we're gonna put that. We're gonna substitute. We're gonna put this one 2y plus 1 wherever we see x. Here, wherever we see the x. So the first part, that's x squared. So we must square it. That's 2y plus 1 squared minus 2y. We do not have x there. Then here, take note, there is x. Then what about this 3y here? 3y is one thing. This is one part, guys. So write it on the same part. This is just like 3y like this. You open the bracket for the x. The x is the one that you're substituting. And that x is what? Is 2y plus 1. That is our condition. The x is 2y plus 1. So here just write as what? 3y. This is equal to 6. So as you can see, we are only left with what? With y there. So you can expand our brackets, guys, solve in as much as you can. Remember, there you can use the concept of a plus b squared, or you can have two brackets being expanded, or you can use a plus b squared. Remember, a plus b squared is equal to what? A squared plus 2ab plus b squared. A being the first term, so that's a squared. What is our first term in this presentation? This is your first term, and this is your last. So we are given a, and we are also given our b here. So we need a squared, 2y squared. So that's 2 squared, which is what? Which is 4y squared. So this one, the first part, we're gonna get 4y squared plus 2ab. That's 2 times our a is what? That's 2y times our b is 1. So if you multiply this, you're going to get plus 4y there. 2 times 2, that's 4. All right. Then plus b squared, which is the last term squared. What is representing our b? It's 1. So 1 squared, guys, is just a 1. So that was going to be plus 1 there. Or you can just expand, guys, 2 brackets. All right. You take these in 2 brackets. We have 2y plus 1, another 2y plus 1. We expand as usual. We were going to get the same answers. So I want you to do that and prove if we're going to have the same answers there. Then the rest simplify. There is a minus 2y there. Here, there is a bracket that need to be expanded by you. You're supposed to expand here, this bracket, by what? By the number that is outside, or the term outside of the bracket. So in our case, there is a term that is outside of the bracket, which is what? The 3y, this one. So you're going to multiply 3y to the what? To 2y. So 3 times 2, the 6y squared, y times y. Then we multiply 3y times 1 positive to positive. That's a positive. That's 3y, which is equal to 6. We have a quadratic equation. The highest exponent is 2. So let's simplify if truly is going to give us, because sometimes it can cancel. So let's see if it's going to truly give us that quadratic. There is a y squared here. There is another part of y squared there. So we're going to add these 2 terms. 4 plus 6, which is what? Which is 10. So we're going to add 4 plus 6, which is 10y squared. Then we move to the part of y on its own. There is a 4y here. There is minus 2y here. There is a 3 there. All right, so this one we can just use our calculator, or you can just simplify, guys. It's up to you. 4 minus 2, like this. The last one we said is what? 3 plus 3. So that's 5. So meaning to say it was going to be 5y. All right, we were going to have plus. It gave us a positive, this one. So that's plus 5y. There is a 1. So we're going to have plus 1, which is equal to what? Which is equal to 6. So that is what we were going to have. And from this part, we can see that our quadratic equation has been formed properly, but we know one of the sides must be equal to 0. So you're supposed to take the 6 to the other side, becomes a negative there. So that's, we're going to subtract the 6 here, which was going to give us 10y squared plus 5y there. 1 minus 6 is what? Minus 5. So that's minus 5, which is equal to 0, like that. So let us solve using our quadratic formula. Factorization is up to you, but just also try to reduce your equation if they are factors by 5, by 5, by 5, our highest common factor. So what we're going to have, 10 and 5, that's 2y squared. 5 and 5 was going to cancel. That's, we've got y there. 5 and this, that's minus 1, is equal to 0. So this is what we are having. From this equation, we can factorize, apply our quadratic formula if you want. All right, so as you can see, guys, we're going to have 2 brackets. The coefficient of y squared is not 1. So it will be best that we just apply that our concept of the cheat method, where we said 2y squared plus y minus 1. We take this, we steal it, we multiply it to this term. So it will be y squared plus y minus 1 times 2, which is 2. you factorize as usual since there is a 1 here. So that's y and y there. What are the products? Sorry, the factors of what? -2, which are the products, but they must give us a positive. A positive what? A positive 1. The number is not given, but you must know that there's a 1 there. -2. But we must get a -1 from a -2. That's -2 and 1. 2 and -1. If you multiply these two numbers, you're going to get a -2. But which part, when you add now, when you add like this, you must get a +1, +1. So that's 2 and -1 here. That's +1. This one was going to give us a -1. We need positive. So we need 2 and what? 2 and -1. So these are the two numbers, 2 and -1. Bring back the 2 that we stole here in place of y, where the y is, you multiply by 2. So here there's a 2, guys. Sorry for this. Okay, let me just write. So it's going to be 2y - 1. So here it was going to be 2y - 1. Okay, something about my sensor here. All right, no problem. So that is the case, guys. This is what you're going to have. And you can factor out whatever that is common in these two brackets. There is a 2 which is common. So you're going to factor out 2, that's y plus 1. 2y divided by 2, that's y, 2 and 2, that's 1. And this part, nothing is common, so it's going to remain as it is. But the factored part here is going to be cancelled. It's no longer important. So we take this as our brackets. So these are the brackets that you're supposed to obtain with your method or with this method. This is what we're going to have. As long you've got these two brackets, the order does not even matter to say which bracket started. All right, so that is where we are. We can solve for y there from the 0 concept. One of these two brackets must be equal to 0. So therefore, we can say this is equal to 0 or 2y - 1 is equal to 0. So what is the value of y from the first part? -1 to the other side was going to be, 1 to the other side was going to be a negative. Or y is equal to the -1 to the other side was going to be +1. Then we divide by these 2. There's a 2 there. So we are going to divide by what? By 2. So y is -1 or y is what? 1/2. For these values of y that we determined, remember that there is an equation that we had written before. Not like that we wrote, but it was given. Remember that equation, guys. X is equal to what? 2y plus 1. Already x is the subject there. Already we have x is equal to 2y plus 1. So from that one, take it as an advantage. Remember, x is equal to 2y plus 1. So substituting this part of x, the values of y that we calculated when I have our x values. When y is -1, in place of y there, we substitute a -1 plus 1. So that was going to give us the value of x. Use your calculator. That's 2 into what? -1 plus 1. So that was going to give us a -1. Or on the other part, for the same equation, but a different value of y. 2 into what? Into a half plus 1. So the y that we are substituting is 1/2. So in place of that value that we had that we have in the bracket, I'm gonna put 1/2. The value of y there, 1/2. So that's it. Our x is gonna be what? Our x is going to be +2. So this is what we're going to have. So these are the solutions that we're going to have, meaning to say, we can even say when x is -1, y is what? -1. We can have it as -1. -1 is a point, and another solution when x is 2, y is what? Y is 1/2. Is the presentation thereafter is in your hands. But that is what you're supposed to have at the end. So make sure that you do go through many questions as you are preparing. So for those who wrote this test, which is, I'm actually failing to pronounce this school, but just pronounce on the comment section. There's no need for you to write it because already you can see the name. But for those who wrote this test, and for those who are revising just because they're going to write another test, guys, do revise in as much as you can. And also work with revisions, your past exam papers. All right. Understand your questions. How are they given? Because you're going to be having similar questions even on your finals. So as you are preparing for your SBA marks, also prepare with a mind that these questions will be very, very familiar and similar in your final exam. So it's not about just here, but it must be of minding the final exam that is coming. So let's do revise in as much as we can till we meet again.